Hello, in this video we will do an analysis of a steel rod as shown in this figure. There will be a steel rod with a diameter of 0.02 meter and length of 0.3 meter. The rod will be fixed at one end. It will be called a fixed support face, and it will be pulled by 1000 kilonewton at the loading phase. On the right hand side we see the code used by Code Aster. Here we can see the modulus of elasticity is 2 exponential 11, Poisson ratio of 0.3, and yield stress of 400 megapascal. In this analysis, we will be using a nonlinear analysis type. For that, we will need to define function as well. The upper part shows the function to carry out the analysis itself. In this case, we will use 10 steps from 0 to 10 with interval of 1. In Code Aster's language, it is called defi least real, and debut means the starting point 0, interval means the interval, and Jacques A means the ending point, while pass means the interval on which the time step will be increased. Similarly, we will also define a function for load that will be multiplied for each analysis. By this, what I mean is that the force function will be increased according to the defi function, while the analysis itself will be based on the list R. Okay, hopefully it is a bit complicated right now, but it will be clear as we do the analysis. Let's get started. First, let's open a new file. Then let's go to the geometry module to create a steel bar with radius of 0.01 and height of 0.3. That's all we'll need, but we'll also make a couple of groups. The first group will be of loading phase. We have to select the phase, add it, next we'll make group for the support phase. We may need to turn the model, then select the phase. Another group will make a group of whole solid bodies, that is the steel rod. And that's all we'll require. Now we go to the mesh model. We'll select the geometry. We'll use a simple algorithm with all its default setting. Then we compute the mesh. Now the mesh has been prepared as such. Now we'll create the group using the group of the geometry. apply and close. Let's rename the mesh to mesh rod or rod mesh. Let's check if everything is correct. Yeah, seems everything is correct. Now let's save the file. Let's call it study1. Now let's go to the Aster study. Let's add a stage file. First we need to read the mesh. Then we need to assign the finite element method. We'll use mechanic everywhere using 3D elements. Now we define the material using define material GC instead of define material. This is another way of defining the material. Acer means the steel. This helps civil engineers to import the material property easily. Sy is the yield modulus of elasticity. Skip Poisson ratio of 0.3. Hit OK. Let's rename the material as steel. Let's assign the material now. Let's assign everywhere the material steel. Now we'll define the functions. First, let's define the load multiplier. We'll select the time as the parameter and we'll input the coordinates. The load will be 0 at the 0 instant. It will be 1 will be at the 1 instant. We'll use a linear function. For that we need to allow right extension and left extension to be linear so that calculation can carry on even when time will be more than 1 or less than 0. Let's rename this function as fload, function load. Similarly, let's define the function for analysis. This is called define list real. The debut, the starting point will be 0. For interval A, we'll have a time step of 1 up to 10. This means load will be applied up to 10th second or 10th instant. Now let's apply the boundary condition. First, let's do the support. Let's define degree of freedom by fixing dx, dy and dz as 0. We forgot to select the elements. Let's select the loading phase, support phase. Hit OK. Next, we'll define the load. Name seems okay. Let's choose force phase. Supply Fz of 1000 Newton. This will ensure the force is in tension. For group of elements, we'll select the loading phase. Hit OK. Now let's go for the analysis. In this case, we'll select static nonlinear analysis. Let's add the boundary condition. First is the support itself. The second is the load, and we need to multiply the load with the multiplier function. For calculation, we also need to give the time step function. Let's also assign the behavior of material, that is comportment. Let's choose elastic bone mesh linear. This is for steel. Let's apply for everywhere. Press OK. As this is nonlinear analysis, we may also have additional function. Let's apply method as Newton, and let's use elastic method instead of tangent. Let's also check the convergence criteria. There are many functions. Let's only choose the maximum iteration. Let's make it 100. Let's press OK. Now let's define the output file. Is use the mate format and define the file as result.rmate. Inside this file, we'll put the results of static nonlinear analysis. That's all we have to do. Let's save the file and let's run it. Seems everything is okay. Let's open the file in Paravis to see the deflection. Let's open the file, result.rmate. Yeah. Let's also calculate the vector that will define the direction of displacement. For that, let's uncheck unnecessary things. Only check the displacement. Click on generate vectors and apply. Let's apply the filter. That is wrapped by vectors. Now we can see the displacement as well. On the upper right corner, we can see the time step that we applied. Thank you for watching this video.